Families in Revit. To begin with, there are two types of families or categories of families that Revit uses. There are system families and standard families. The system families are the families that live within the project of Revit, and you've been using them all along in this semester. They include things like the roof, ceiling, floor, and walls. These you create in Revit, modify in Revit, and they live in Revit. The standard families are families that live outside of Revit. They are their own file. You've also been using these throughout the semester, and they are the objects that you have imported into your project. The desks, the lamps, anything that you use to render the entourage, those are all standard families. Today we'll take a look at how to create a standard family and be able to make different family types within that family. So we can flex the model and have different types available within the project. To begin with, we'll need to load a generic template to use. We'll do that through our File tab here. We'll create a new family. When we go to this dialog box, Revit wants us to pick a family template that most closely resembles the family we're trying to make. We'll go ahead and make a table that has different dimensions for the different family types, but we'll use a generic template for now. So we'll use a generic model template for this family to make things more simplistic and easier to learn. We'll open that file, and you can see when we file, we should save as, and when we do a file save as, we'll save it as a family. We'll go ahead and save it on the desktop, and we'll call this family 1 is fine, and then we'll finish the name with table. Once we finish creating our family, this table, and the different types and the different parameters, we'll go ahead and load it into a project and see how it reacts. When creating a family, reference planes, these, are everything. You'll use them, and they will be used to flex the geometry, and you'll attach the geometry of the family to these reference planes. You'll also attach parameters to these reference planes, and that's what allows the family to flex. Flexing is when it changes dimensions instead of you having to actually change the physical model of it. You can just type in the new dimension and the model will update. So we have two reference planes by default, and these are the center. And so the center of your family will be in the middle of these. We're going to create two sets of two more reference planes, and these will define the boundary of our tabletop. Doesn't matter where we place them, but we're going to place them two horizontally and two vertically. Doesn't matter because we're going to add dimensions, which we will then apply a parameter to, and that's what the geometry will be attached to be able to flex. So reference planes are very strong in families. That's what we'll use to control everything. Next are dimensions. So we'll go ahead and create some dimensions. Not only do we need the dimension for the length of the tabletop and the width or depth of the tabletop, but we'll need to center these reference planes around the two main reference planes that came with the template. This will keep the new family, no matter how big or small it gets as we flex it, centered around the middle. So we'll go ahead and add some more dimension lines. And when we add these, we're going to make sure it is selected along the center reference plane as well. And we're going to select this equal button right here, and that will keep the two reference planes equidistant from the middle one. Next, we'll go ahead and select one of the reference planes and change that dimension to a round number. So now we have two reference planes vertically that are always going to be equally spaced from the center one. And then we also have a dimension that will dimension the entire length between the two. So we're going to do the same for the horizontal reference planes. We'll dimension it, we'll equal it. Now keep in mind you don't want to lock these equal dimensions. Even though it says equal, you don't need to lock the dimension to tell it that it's going to stay equal. It will always stay equal. Therefore, what does the lock really mean? The lock really means it will lock whatever dimension this is. Even though this is not showing a dimension, it has one, and the lock will keep it from there. And it will over-constrain your model if you try to move one of these, because they'll try to stay equal on each side, but you were telling it to stay at a certain dimension. So, bottom line, don't lock the equal dimension that you've just placed. And again, we'll select one of the reference planes and we'll make this a round number. Very good. Next, before we even create some solid geometry, we're going to apply some parameters to these two dimensions. That way we can flex the model. And if we can get the reference planes to move when the dimension changes, then it'll be easy to create solid geometry that does so as well. To create a parameter that's associated with this dimension, we select it. Up here in our Modify Dimensions tab, we see a label, and this is our label dimension panel. And we have not created any new ones, so no labels show up in our drop-down menu. But we can create one. A label and a parameter are basically the same thing. So we can create a parameter here. And again, this was highlighted, this dimension here. So this is the parameter that we're adding up. This is the dimension that we're going to apply a parameter to. So we'll name this length. And this is where we decide if we want it to be a type or an instance parameter. Usually the dimensions of the object are type parameters. And we can hit OK. And you can see that it is now labeled length, and that is one of our parameters. We'll do the same thing for here, and we'll call this one width. It will also be a type parameter. So now we have a length and a width. If we grab one of these reference planes, we can drag it. You can see that the other one will always stay the equal distance away. But let's add some parameters to this and see if we can modify the reference planes through the parameter. Over here on our properties panel, we can find a family type icon, and this is where we can add some. So we'll create a new parameter, new type here, and we'll name it 48 by 24. You can see that our length and width parameters are in this dialog box, but we need to match it to the name that we just gave it. We have the length right, but let's change the width to 2 feet. When I press apply, let's watch in the background and see if the width actually changes. And it did. And we can go through and change these to whatever we need and make sure that they actually change. And you can see the width has changed to 5 feet and the length to 10 feet. I'm going to go back and change this back to 4 just so that it remains consistent. So now we have two parameters that are controlling the reference planes, and we'll add some solid geometry that will be controlled by the reference planes. So now we need to go to our Create tab. We're going to create an extrusion in a rectangle, and we will select that intersection and that intersection. Now we'll need to go through and lock all of these lines to the reference planes. We'll hit OK. I'm going to shade the view, and you can see the solid geometry there. And if we go to the parameters, again, we can change this to any dimension, and you can see that the solid geometry was changed by the reference plane which was changed by the dimension or the parameter. We'll go ahead and go back to here and put it back to our 4 feet by 2 feet, and you can see that it's working. I'm going to go ahead and look at the 3D view, and you can see that it's quite a box. And it's probably too thick. Let's see. So now we need to make the tabletop the right thickness. So here we have it in 3D view. Here we have the top view of it. And here we have the side view of it, or the front elevation. So from the front elevation, we'll add some reference planes to give it a dimension for the height of it. And then we'll actually lock a reference plane to the thickness. So we're going to create 2 new, and again, it doesn't matter where you place them at first. We'll create 2 dimensions, one from the floor level or the reference level. So whenever we import this family into a file, it'll use this reference level to place it at the level in which we are placing the family into the project. So now we have a height, and then we're going to create a thickness to this, which we could make a parameter, which means it could flex or change. But instead, I'm going to go ahead and highlight that reference plane and just make it 4 inches thick. And to make sure that it's always 4 inches, I'm going to highlight the dimension and I'm going to lock that 4 inches. Now, whenever the top of the tabletop, this reference plane moves, the bottom one, which is the 4-inch thickness, will move with it. Now we might want to have this family be able to change its height as a parameter. So we're going to select this dimension. And again, we're going to create a new parameter. We're going to call this one height. And this one will make an instance parameter. Hit OK. And now we have a height. If we go to our family types, you can see that the height has shown up. And we can change this. And if you look over here, when I press OK, you can see that it was reduced in height. And the next thing to do is attach the solid geometry to these reference planes. You don't have to modify this or edit this solid geometry. You don't have to edit the extrusion because you have these grips, and you can just pull the top of it until it attaches to the top reference plane and lock it. And then you can do the same with the bottom of the tabletop and lock that one as well. Now, when we change the height, okay, let's try that again. Remove constraints, we're going to lock that one, and we're going to lock that one. And let's try this one more time. 3 feet, apply. Now that I'm not sure why it didn't attach the first time, but it looks like it's working now, and I'm going to keep trying to make sure that as we change the parameter of the height, it's changing the distance of the reference plane from the reference level, and with it the solid geometry is going with it. And try it one more time, take it back to 3 feet, and hit OK. And it looks like it's working. So now we can add some table legs. To do that, we'll go to our floor plan level. I'm going to go ahead and change it to wireframe so we can see through. We're going to need to create another extrusion. And this will be, we'll just make some square legs. And we're just going to put it right here. Now, we should constrain the geometry of this table leg so it's always the same distance from each edge as well as the same size. So we need some dimensions here in both directions. I'm going to go ahead and pull this to the outside of the table just to keep things clear. And I can select this first line, and we'll just go ahead and say we always want it 2 inches from the edge of the table, and we want the table leg to be 4 inches. We'll do the same thing here. This leg wants to be 2 inches away, and we want it to be 4 inches wide. we look at it in 3D. There it is. You can see it down there. Let's go ahead and look at it in elevation. Well, let's finish the extrusion right now. And you can see it over here, and you can see it in 3D. Just like the tabletop, we'll go ahead and highlight it in elevation. We'll grab the grip, and we'll connect it or attach it or lock it to the bottom of the tabletop. We actually didn't attach it to the tabletop, we locked it to the reference plane. So before I go any further, I'm going to try and flex it and make sure that the leg is going to follow the height. So we'll go back and play with this, and you can see the top of it is staying with it wherever it goes, and so it looks like it's working. I'm going to go back to my floor plan level. I'm still in wireframe. If I shaded this, I wouldn't see that leg because it's below this tabletop, so we're going to stay in wireframe. Now I'm going to highlight this leg, and I'm going to edit the extrusion. I do that because I'm going to create the other 3 legs all within this same mass. So I want to be in sketch mode here, and I'm going to select all of the dimensions and the 4 sides of this leg, and I'm going to mirror it around the middle. And not all of the dimensions came with it, and that's okay. We'll have to fill that in. But now I'm going to select the 2 plus all the dimensions and mirror it around the other axis. So now I have 4 legs, and I just need to make sure that every leg has a dimension in both directions. You can see the first leg that we created has a dimension from the edge. If I change this to, let's see, do that, we can see that it has a dimension from the edge to the first side of the leg, and then a dimension for the width of the leg. Same in both directions. So we need to make sure that all 4 legs have all of these dimensions. So we'll go over here, and this one is missing 1. We can just highlight the dimension and edit the witness line. And we want to make sure that we do all the legs. And this one is just missing the 1. And then the last thing we need to do is go around and make sure that they are all locked. I'm going to make sure that every dimension is locked so that it's always 4 inches by 4 inches in size, and it's always 2 inches away from the edge in both directions. And that's what locking all of these dimensions will do. So no matter what size the tabletop becomes, the size of the legs will always stay the same, as well as the distance from the edge. And we'll finish that mass, and we'll take a look at it in 3D, and I think we're good to go. And so now we can take a look, we can look at it in 3D, we can change the parameters and see if everything is going to work the way we want to. I recommend making this very big and very small in all of the dimensions, because if you're going to have a problem, it's good to see if it's easiest to notice when you go to the extremes. So we can make this 2 by 2 by 2, hit apply, and it looks like the legs went with it as the table shrank and got shorter. And what if we went 25 feet by, it's a very big table and very tall table, 25 feet in all directions. Zoom extends, and you can see that the legs did exactly what they were supposed to. So now I'm going to go back to my properties. I'm going to make it my 4 feet by 2 feet and 3 feet tall table. Now that we have the table, I'm going to save it. I'm going to close all the windows but the 3D view and our project. So this is our project file over here. This is our project file that we had over here, and this is our family, our table. So I'm going to load this table into this project. I'm going to create some walls just for reference. And maybe we'll take a 3D view of that one as well. So we've got our table over here on the 3D view, and then we've got our project with our 2 walls over here. So let's load the table into this project. If I type in CM for component, I can load the family, and I know I put it on the desktop, and it's down here somewhere, family table, there it is, and I'm going to load it, and I'm going to place it right there, and there's our table. And if we highlight it, you can see that it only has one family type, and that's the one that we created when we made it. We can create more family types, meaning more sizes of the table, either in the family that we want. If we know we're going to use a 48 by 24 inch table often, as well as maybe a 2 foot by 2 foot table, we might want to create both of those family types within this within this family file. So we'll make another one called 24 by 24, and we'll change all of that. And we hit OK. So now you can see that this type name, 24 by 24, is associated with these dimensions, 2 by 2 by 2. And then if we go to the 48 by 24, you can see that this type name is associated with these dimensions. We'll hit OK. Now we can also load this table, or reload this table, into our project by being in the family file. We can look at the Modify tab and look right here. If we load into the project and close this file, once it's loaded, it'll go away. Or we can load into the project and the file will stay open. So we'll load it and we'll overwrite the existing version and its parameters. So now when we highlight this table, we can see that it has come in with an extra family type. And we can change from the 4 by 2 foot table to the 2 by 2 fairly simple, just by changing that. In fact, we can copy this, highlight one, and change that one back. You can also create family types within the project. Say we wanted a new table type that was a square 5 by 5. We can duplicate this within our project file, change the dimensions to match the name, 5 feet by 5 feet, hit OK, and you can see that it is now a square. And let's copy this one more time. So we can change this one to our 4 by 2, this one's our 5 by 5, and this one is our 2 by 2. And that's how you create new family types within the project.